Welcome to a new test and teardown video. This time it's a high voltage tester from Danbridge, so it's a Danish brand, and this model is called JP12A. I actually also got a JP2 stocked from old times, so maybe I'm going to have a look at that one as well, and maybe in another video. I don't know exactly how old this one is. It's not presented on their web page, this model, and today it's called a JP30, and it can actually do 30 kilovolts. So I guess the 12 here is for 12 kilovolts. Well, this is just what I guess, but the JP2 can also do 12 kilovolts. So I don't know. There's this handle, and I guess you push this button, then you activate the high voltage to the tip, and then you can measure if there is any arc or whatnot. I think that is the idea. And the way that this works is, this is of course the meter range, and I would also assume this is the current limiter, and then you select the voltmeter range, and then there is the high voltage adjustment. And here's a really cool thing. There's a loudspeaker and a little loudspeaker amplifier, and that is actually the current, like an AC feed from the current, and this is amplified so you can hear if there is any starting to arc over or some current that is flowing in your test circuit. And you can even connect some headphones if you want to, and they do warn a little bit about using the headphones so you're not going to electrocute yourself. That is pretty good idea, right? So if you put this around your head, I don't know if that is a good idea. I don't know if this unit works or not. So that is going to be very interesting to see in a second. I will power it up. I just want to have a little look at the back. So what have we got here? Meter output, 5 volt full scale. Oh, we also got both voltage and current output on that one. We got some cooling here for transistors, and we can select input voltage ranges. I guess you have to pull this out to turn it, and there's a fuse in here. I don't know why. You can lift it here at the back. Maybe, yeah, okay. This is actually just to protect it if you put it on the floor, I guess. And then there's this Danbridge. Yeah, well, let's try and power it up and see if there is any kaboom in this thing. I think we're ready to try and power it up. I just connected everything together like that because I actually don't like to touch anything. I don't know what is coming out of this and that, and I don't know what's gonna happen. So first of all, we just turn on mains, and then we're gonna see. Nope. I hear something. Can you hear it? A little bit of hum and good things. I think we're going to try with the lowest current range, and we're going to 6 kilovolts. So we don't know what we're doing here. There is no. Okay, so that means you need to push the button at the same time. Aye. Okay. So that's 600 volts. That's a really nice, this is really bright. Uh-huh. What is this sound? That is weird. It continues a little bit. Ooh. Ooh, ooh, ooh. That, can you hear this? The relay was broken. The relay was failing, and you could hear something was going on, and current was going on. Oh yeah, and voltage was actually also coming out. Oh, I better make a better setup here so you can see what is going on. This is better, right? How about we crank this up? Let's crank up the fun, right? Did you hear that? There's definitely spark over somewhere, and that is probably in the cable or in its scary shit, huh? Here again. Oh, voltage is raising. Look at the amp meter. This is funny. But why is it going? The amp meter is really scary. Let me take down the voltage. This is not so good. Here you go, 600 volts. And then the... of course. It's because my... Okay, look at that. We of course need to be in a higher range, right? Yeah. Then it's going to drive the voltmeter probe, right? No, there's definitely a problem with the high voltage sparking over somewhere. Of course stuff don't work. This is why it lands in my lab, right? So I have to open and have a look. And we are inside. I can hardly breathe because the smell is very, very intense. It smells of high voltage arcing and all sorts of stuff here. So that is the logic board with some op amps and some stuff here. I guess what we have here is actually a little half-bridge driver circuit, right? And this drives a high voltage step up transformer. And then we got, look at that, diodes here, capacitors. Oh, we also got some diodes down there. And this is ground. What is that? Oh, there's a screw missing. Whoa, look at that. There is a screw missing. Really? That is weird. You know what I think that is? That is a plastic screw that broke. Right? Yes. So that means this part should be this cable. Okay, this cable got its ground here anyway. So it's not the end of the world, but this can't be correct. Uh-huh. Yeah. And here is a voltage measurement. That resistor goes here, and probably some other resistors. So this is a voltage divider from the output and measuring the output voltage, and that seems to be working quite good. I don't understand what exactly that is doing here. But we got extra filters, so it's really nicely filtered DC. And then the diodes. I mean, where is it arcing? I don't know yet. I think I will try again and turn off the light, and maybe I can see where it's arcing. But that is quite interesting how this was done. It's very, very simple. I didn't expect it to be that much full of air. Okay, that cable goes here with this switch. Let's look a little bit. Yeah, exactly. Let's look a little bit on that tester cable. So as far as I can see, it's a double shielded test cable. Look at that. So there's an inner shield that goes to the ground. And then the outer shield is what goes to the bulb. So that is probably when you connect that one to that ground, right? Then it activates. And then there's a positive voltage on the other side of the bulb. And then that signal goes to the enable good things. Oh, so it's the same board here also for the JP30. And that is the current version. If you look on their web page today, it's called JP30, and that goes to 30,000 volts. Op amps in sockets, nice. Yeah, everything here looks quite alright. It's beautifully designed. I mean, except for the smell, the super intense smell really. So those diodes, what is that exactly? I'm not sticking my fingers down here, but that transformer is just fantastic. Why are we having that many wires to that? Because I don't understand that yet. Can't be that many. Ooh, this is loose. So that is of course the primary windings, and since this is not generating a lot of watts, you don't need a lot of copper here. I actually see two wires coming out of the primary too. One is of course going up to that capacitor. So this one is a voltage Doppler. So this is why you go into the capacitor first, and then a diode from ground, and then it goes positive, poof, you go double voltage on that one, right? And then it's just filtration. Can't wait to see what's written on those. Yes, 16 kilovolts, 470 picofarad. That is what you see on those capacitors. It's nicely in a little box. I wonder what frequency this is running at. But this looks like an old TV set core. So it's probably 16 kilohertz or something around that, right? Because of the ferrite materials in this core is specially optimized for that. This is just my guess, but it really looks a lot like an old TV set transformer, right? So I've been looking a lot more inside this unit, and I now know a lot more how it's working. like I said before, yes, this is indeed the voltage measurement, but that one is the input for the audio amplifier. You see the two diodes that goes each way. That is to make sure you don't get a too high voltage into the audio amplifier. So this is just a decoupling capacitor directly from the output. So if there's any audio, or any arcs, or any varying, changing in the currents, you will get a voltage difference in here, right? And then that will be amplified. So this is of course ground, and so decoupling is only that one. So that is how it works. The primary winding is actually two windings, and they are black and gray, both of them, as you see here. Two blacks and two gray wires for the primary side, and one black and one gray is connected together to a positive power rail, and then the other two sides goes via two capacitors. So it's AC coupled to the two Darlington. I think those are tip 31C. So this is most likely NPN Darlington, if I'm not wrong. And then the secondary side, the high voltage side, actually also got some extra wires coming out of it. Not just a single ground. And that is, of course, feedback windings for the oscillator. So this is a self-oscillating circuit here. And that signal to this transistor is that one. And that green one here is the wire to the other transistor oscillator. So that's actually a push-pull self-oscillating circuit. So that's quite simple. There's probably some sort of a duty cycle kill. That means this is how it regulates the energy level, and this way also the voltage, because it's got variable voltage. Something like that is what I guess, because I haven't seen exactly how that works. I don't have a schematic for this, so I'm just, looking a little bit here and guessing how the heck are they handling the variable voltage, because that is super smooth the way that works. So now I need to figure out where is the arc smell coming from, because there's definitely something that hammers over somewhere. So I've been investigating a little bit using a thermal camera, and it's not in the secondary or in the high voltage we got the problem. I don't know if you can see this. It's actually quite a while ago since I powered this. Look at that, 200 and something degrees. Are you kidding me? And it was 300 before, because I've been running this a little bit. So down here, it is that easy. Down here is a resistor, that one. I think that is broken. And what we hear here is a spark over, so it's 47 ohms. And this is probably a current sense resistor from the primary side to ground that is broken. I can even read, it says 47 ohms. Definitely why this is not working. Great. Oh my God, it is a little bit difficult to come all the way into this resistor. I mean, I needed to remove the transformer to access the nuts on all the transistors here, and then I can probably get this out, but then there's this connector. I need to remove the wires from that one with desoldering, because there isn't, of course, no connector here. I mean, really? And there's no way to access the bottom of the PCB while the PCB is still mounted. So it's not the most service-friendly design. As you can see, you need to completely disassemble everything, and then, I mean, you can only test this when it's back again, and it's, really? That's going to be an all-nighter. That was real fun. Now we're in, And this is the resistor. But there was a Zener diode across the resistor or something, and here is a shorted something. So let's have a look here. We got a little bit of modifications done here, but also look, now I grab the resistor, right? Look. I don't know if you can see this. Yes, here you can go. Here you can see this. Look at that, it's moving. So there is not a connection to that resistor. It's sparking over to that bottom solder point here, right? So this can't be good. So I need to remove this, but I also need to find the cause of that problem. So this is my test. I'm also testing with thermal imaging, and yes, there's definitely resistors running quite hot here in the power supply, those two right there, but it's actually working. You can hear. Ooh, scary. So that is more or less how it is. Wagadaboop, gadaboop, ba poof. It is the magic wand, this, you know, it feels a little bit like that. So